grayscale is correct. In this problem, we're supposed to take in an image and apply a filter to that image and output the image with that filter. So this R represents reflected, so we are going to get a reflected version of this image. So to do this problem, first of all, you should download this file using this command and then unzip it and then cd into this directory. Meanwhile, smash that like button. So we're going to go into helpers.c, and then inside this we have 4 functions which we need to implement. The first one is grayscale. To implement the grayscale filter, we're going to iterate over all the pixels. So every pixel is inside image ij. Okay, so we are going to iterate over this image matrix or image array. To do that, I'm going to start off, I'm going to say int I equals 0, I less than height I plus plus, and for int j equals 0, j less than height j plus plus. And after doing this, we are going to look at the pixel. So this is going to be a pixel. I'm going to say pixel equals this. So this is going to be RGB triple pixel. Okay, this is our pixel, and then what we can do here is we could say that the ith, change the I image at the ith and the jth location, which means we're going to change a particular pixel, and we're going to set this pixel, we're going to set the red of this pixel, so we're going to say RGBT red. We're going to set the green of this pixel, RGB. I'm going to set the blue of this pixel, all of them, to this average value. Okay, so what is this average value? I'm going to say int average. So to make an image or a pixel grayscale, what we do is we look at all the R, G, and B values, and we take the average of them. We look at the pixel.rgbt blue, RGBT red, plus I'm going to look at the green value, RGBT green, plus I'm going to look at the red value, sorry, the blue value, RGBT blue, and then I'm going to divide, and since all of them are integers, we must do a floating point division. So I'm going to divide this by 3.0, and then I'm going to round this thing up, since I need all these values to be an integer value. So I'm going to round this up to an integer, store it inside average, and then to use this round function, I'm going to use the math.h library. So after having done that, we can simply move on to the next function, sepia. Sepia is an interesting one. In sepia, what happens is there's a formula that has been given to us. Okay, the formula that has been given to us for sepia is this. And so what we need to do is we need to take the original red, the original green, and the original blue, and then we need to apply that to this formula and assign the new pixel value to be this. Okay, I'm going to do that over here. What I'm going to do is I'm going to iterate over the image. So I less than height, the same thing. I'm going to take this and I'm going to copy paste this. This is going to be width over here. I'm going to iterate over this image, height and width, and I am going to say RGB pixel, RGB triple. I'm going to get a pixel out of this, put a semicolon over here, and then take an RGB pixel, and then I'm going to set the current value of red. I'm going to mutate this value, I'm going to change this value, and I'm going to use this formula. Okay, so I'm going to use this guy. I'm going to use this original red, and it's original blue and original green. And what is the original red going to be? Original red is going to be pixel dot RGBT red. Int original green is going to be, or the original blue RGB is going to be pixel dot RGBT blue, and original green is going to be pixel dot RGBT green. Okay, and then what I'm going to do is use this formula, but this is going to convert this entire thing into a floating point value. I have to round this value. I'm going to use a round function. Okay, similarly I'm going to copy this formula over here for RGBT green, and it's going to be, I'm going to say image ij dot RGBT blue, maybe this guy, and image ij dot RGBT green is going to be this one. Okay, see, we have changed the image accordingly. And you know what? We need to round this by round function on all of these things. And then we're going to use, we have to cap this value to 255. So I'm going to define a function called cap. Define a function called which returns an integer. Cap takes in a value, and what it does is, if it so happens that the value is greater than 255, then I'm going to return 255. Otherwise, I'm going to return the value that has been given to me by the parameter. Let me just this thing, and I'm going to use the cap function over here to cap this value, cap all these values, and after having done that, this should work as advertised. 0 point this. Alright, now after having done this, we have completed sepia. The next thing is going to be the reflect function. To reflect something, what needs to be done here is we need to iterate over the image, its height, and we need to iterate over half of the image, half of the image's width. So I'm going to say width divided by 2, okay, because I need to swap by, I'm swapping essentially something at the beginning, something at the end, okay, n-1. So I'm going to swap the 0th element with the n-1th element, something like that. I'm going to swap the image, the ith, at the ith row, jth column, with image at the ith row, but width -1 minus ith column. So we are swapping 0 and width -1 first, then we're swapping 1 and n-2, and so on. So now we need to write the swap function, but you know what? Swap will take the value of the image, and it won't take, we won't be able to swap them until we take the addresses of these values, and then we are going to swap them because we have pointers to these values. So instead of int star as seen in lecture, we are going to take an RGB triple star pixel 1 and RGB triple star pixel 2, and we're going to swap these two pixels. So I'm going to say I'm going to have a temp variable RGB triple. Temp is going to be equal to pixel 1. Pixel 1 is going to be changed to pixel 2, and then what's going to happen is pixel 2 is going to take the value of pixel 1, which is now stored in temp. So pixel 2 is going to take in the value of pixel 1, which is stored in temp. After having done this, we should continue with the next one, which is blur. The blur is a little tricky, In blur, what we're supposed to do is we're supposed to figure out the blurred pixel corresponding to the current pixel, and then we're going to mutate that image of I and j afterwards. So the difference is going to be, we in the blur function we cannot change or mutate the value of image ij. The reason being, if you change the value instantaneously, then you won't be able to find out the original values, okay? So you must, in this blur function, you must take, for example, for this value, you must take the average of all these values, okay? Now if you mutate all these values before coming to this value, then you don't have access, or you have lost access to information of the original image. So we must store the original image somewhere, and then we must do all the changes inside a new image, and then copy that new image into our original image. Okay, so I'm going to create a new image over here. Let's get rid of this return because it's unnecessary here. So in blur, what I'm going to do is I'm going to iterate, I'm going to create a new image, triple new image, height and width, okay, for int I equals 0, I less than, I'm going to iterate over the height, and I'm going to iterate over the width, j less than width j plus plus. And you know what, the new image I'm going to make all such changes in new image. So new image of ij. So let's say it's going to get the blurred pixel value. I'm going to define this function. It's going to be the blurred pixel ij. I'm going to provide height. I'm going to provide the width, and I'm also provide this image. Okay, so I need, so the pixel at image ij has height and width as its parameters. Okay, I'm going to do that. I'm going to write that function over here. I'm going to return RGB triple because this is going to return a pixel. I'm going to get back a blurred pixel. I'm going to get this function to get a blurred pixel, int I, comma, int j, comma, int height, and GIHT, int width, and the image. So I'm going to take this guy, image of width, height, width, RGB triple, image height, width. This is going to be the prototype of this function. And now after doing this, I'm going to say, you know what, I have to move one step here and one step up. Okay, so essentially what I want to do is I want to move from here. I want to change this location, and let's call that change di. Okay, so I'm going to move from like -1 for the row, -1 for the row, and -1 for the column. Okay, so I can move from this given ij. I can move one step back, one step forward in the column, and one step back and one step forward in the row. So I'm going to move one step back. I'm going to call this di, which stands for delta I, a change in I. I can move one step back, and I can move one step forward. So this is going to be the loop for this. And then I'm going to say the same thing for the column dj. I can move one step back, and I can move one step forward, dj plus plus. And then what I'm going to do here is I'm going to see if I'm going to create a function for is valid pixel. Okay, so what is the new pixel going to be? So the new pixel that I'm going to look at, is this pixel. Okay, so I can say, you know what, is valid pixel. The new pixel is going to be, or new I and new j. New I is going to be I plus di, and new j is going to be equal to j plus dj. Okay, then I'm going to say if new j or new I, new j, if these are valid, this pixel, the valid pixel, it depends on the height and the width. Okay, so inside this function is valid pixel, what I'm going to do here, I'm going to say is valid pixel given ij, int I, int j, int height, and in width. I'm going to check if I is greater than or equal to 0 and I is less than height, and j must be greater than or equal to 0 and j must be less than the width. If all these conditions are true, then the pixel that you're currently looking at new I, new j, height, and width, the valid pixel, and I'm going to return true in that case. Okay, otherwise I'm going to return false. So now I can look at the red value of this new ij, and I can look at the blue value of this new ij, and I can look at the green values, and I can keep on adding them. Okay, what I'm going to do is I have been given this pixel, for example. Let's say I'm given this pixel. Now I can go and visit all these 9 pixels, and I'm going to find the average of them. So I'm going to add up all the red values, I'm going to add up all the green values, I'm going to add up all the blue values. So I'm going to define over here red value, blue value, green value. Or you can also define a new pixel and set the red values, green values, and blue values to be 0. That would have been sort of a better design in this case. Okay, set all these to 0, and I'm looking at the number of valid pixels. Let me set that number of valid pixels. Let's set this to, initialize this to 0, and then I'm going to, if it's a valid pixel, since I need the average, I have initialized this to 0, and I'm going to increment every single time I find a valid pixel. After having done that, I need to accumulate the value of the red pixels, or the red values in the pixels, blue values in the pixels, and the green values in the pixel. Okay, so I'm going to accumulate all those things. So I'm going to say plus equals the current, the new I, new j is the current pixels, red value, red, blue values, and green values. So I'm going to say I image dot image I plus di. Okay, I'm going to get new I, new j dot red value, image new I, new j is blue value, and image new I, new j is green value. Okay, I'm going to take a look at this. I'm going to change this to RGBT red, RGBT blue, and RGBT green. After having done this, we can now divide all these values that we've accumulated by the number of valid pixels, get the final pixel value, final blurred pixel. Okay, we don't want the blurred pixel, so we have to define a new blurred pixel over here. So let's define blurred pixel, and we're going to return that blurred pixel after adding the red, green, and blue values respectively. I'm going to say blurred pixel dot RGBT red is going to get something. What is it going to get? I'm going to just round value of the red value. I'm going to round the red value divided by number of valid pixels, and since this is an integer, I need to convert this into a floating point value. And so I did floating point division over here. I said red divided by number of valid pixels. So red value, similar thing needs to be done with green pixel and the blue pixel. So RGB, R green, let's say green value. Okay, very careful that we do not mess this up. Blue value, blue value. Okay, let's see, we have the red value, the green value, and the blue value, and we're dividing it by the number of pixels. We have the red value, blue value, and the green values that we're accumulating, and then we are returning that blurred pixel, which this should work. Let's move on to the next function, which is, actually we finished all this, but in this function what we need to do is we need to finally, once we've got a new image, we must copy this new image back into this image, okay, the original image. So I equals 0, I less than height, I plus plus, for int j equals 0, j less than width, j plus plus. I'm going to copy new image into image. Say image of ij equals new image of ij. What it does is it copies every single pixel from the new image to the old image, or the image that has been passed to me as a parameter. So now what I'm going to do is I'm going to run check 50. You should try, I'm going to make this and find out if there's an error first. I'm just going to run make a filter, and there is a value, green value. Say this is green. Let me run this again. J is less than width, j plus plus over here. After this we've got is valid pixel, unknown type blue, bool. So we must add CS50.h, CS50.h over here, and then we've got 4. Okay, we need a comma over here. Pixel RGB number of pixels. This one needs to have a semicolon at the end. Okay, after having done this, let's make filter. Seems to work. Try out some examples. You should look at all the filter flags, so to speak. This R is for reflected, B is for blur, and so on and so forth. I'm just going to skip all that because I need to make this video short. I'm going to just check 50 and check if there's error over here. Meanwhile, let me just summarize what I've done here. First of all, we needed to implement this grayscale. The grayscale had to be implemented by averaging the red pixels, the green pixels, and the blue pixels. As you can see, all of this, oh, this should be J. So swap should be swap jth, I and jth. Let me run check 50. So let me summarize this code. First thing that's happening here is we are using grayscale function to average out the red, greens, and blues. We are setting the red value, the green value, and the blue value of a pixel to the average. We can see grayscale is correct. Sepia. In sepia, what happens is we use this formula and convert the original red, original blue, and original green values. We convert them into our new values, and then we round them off, and then we cap them below 255, and we change the image that way. The next one is going to be reflect. Reflect, it's pretty simple. What you need to do is, for every single row, you need to go and swap the jth and the width minus 1 minus jth column. Okay, and then for blur pixels, what we want to do is you want to move one step, blur thing, I want to move one step over here, one step above, and one step to the left and to the right column, one step up and one step down. There are 9 possible cells that you can reach. You want to check if this is a valid and it's not like somewhere on the side. If it is a valid pixel, you increment this number of valid pixels by 1, and then you accumulate the red, green, and blue values, and then you create a new blurred pixel by rounding the division of red value divided by number of pixels, the green value divided by the number of valid pixels, and blue value divided by the number of valid pixels, and then you return the blurred pixel. Okay, that was the blurred function. So in the blurred function, we need to implement this in a little different manner. What we need to do is we need to create a new image and then get all the blurred pixel values and then mutate the original image, because if we would have changed or mutated the image values as we approached every single pixel, then by the time we came here, all these values, we would have lost access to all the red, green, and blue values of the original pixel. So that's pretty much it. Like, share, and subscribe. Peace.